Everyone overcomplicates this substring problem, but all you need is to remember 3 positions, 1 pass, constant space. Want the full solution? Check this video.
Hi everyone and welcome back. Imagine I asked you a simple question. How many substrings contain at least one letter A and one letter P and one letter C? The brute force solution is obvious by checking every possible substring, but this is very slow solution. But what if I told you we can solve the entire problem in just one pass? Let's see how. Today, we are solving the leetcode problem, number of substrings containing all 3 characters. We are given a string consisting only of characters A, P, and C, and we need to return the number of substrings that contains at least one occurrence of all these characters A, P, and C. Let's first understand what we are trying to count. Suppose our string is APC, APC. So instead of the brute force solution of generating every substring, we will process the string from left to right. And for every position, we will ask how many valid substrings end here. Once we know that answer, for every index, we simply add them together. And here is the important insight. A substring is valid if it contains one A, one B, and one C. So while scanning the string, all we really care about is where did we last see each character. And this is our approach. We will track the last position of each character. So we will keep the 3 numbers by, for example, we will define an array, let's name it last seen, of 3 of size 3, where the first index is to store the last position of A, and the second index is to store the last position of P, and the last position or the third position is to store the last position of C. So initially we will initialize this array with -1. So that means none of the characters appear yet. So let's walk through the example. Again, imagine that our string looks like ABC, ABC. So at index 0, the character is A, and that means the last seen of A is 0. We still haven't seen P or C, so no valid substring exists. So the answer still 0. Again, at index 1, we have character P at position 1, so we will set that index to 1. Still missing C, and again 0 valid substring, so our answer is still 0. Then at index 2, we have the character C at position 2, so we will initialize the third position to 2. And here is the magic. The earliest among these positions is the minimum of these 3 positions. That means that the position that I first see either A or B or C, and this is the minimum between the three positions. So this is the minimum between 0 and 1 and 1 and 2. And what does that mean? It means that every substring ending at index 2 and start anywhere from index 0, and in this case up to index 0, will contain all the three characters. And that is exactly 0 plus 1 equal 1. So we have only a one valid string, which is simply A, B, and C. We will continue our scanning. So again, let's add index 3. The next character is A. But now we have character at index 3, so we'll update this position to 3. Again, we will calculate the earliest position where we first see A or B and C, and the early position is 1. So again, that means that every substring ending at index 3 and starting at index 0 or 1 is valid. So we will have 1 plus the earliest index 1 equal 2. So here we have two valid substring, which are A, B, C, A and B, C, A. And if you still didn't get it, let's move forward to the next index. So at index equal 4, we have the character P. So we will update the position here to 4 and then calculate the earliest position where we see A or B and C. And in this case, it will be 2. And as we have done before, we adding 1 to this position, and that gives us 3. And that means we have 3 valid substrings. And we will continue with the next index, 5. And at that position, we have C, and we will update the position of C to 5. Again, the earliest position now is 3. So adding 1, 2, 3, and that gives us 4 valid substrings. Maybe you're still thinking why calculating the earliest position works. Suppose that the last scene, for example, if we have last scene, equals something like 8, 12, and 10. The earliest position here is 8. The earliest position here is 8. If our substring ends at the current index, then every substring start at positions 0 to 8 will include all the 3 characters. And that exactly 9, and that exactly 9 valid substrings. Which is why simply we compute our result as the earliest plus 1. And that's the whole trick. So let's now move to the code. First, we need to initialize our last seen vector. So last seen of 3 and -1. Then we need also to get the length of the string and find the total equals 0 that will hold the final answer. Then we will loop through the every position in the string. So for int position equals 0 and position is less than the string length and plus position. And in this case, we will update the last seen vector by adding the current position to the assigned character. So S of position, and this give us the assigned character. And don't forget to subtract the lowercase a to get the integer value equal position. And then we append to the total 1 plus calculating the earliest position, which is the minimum between the 3 positions. The last position of 0. This is for letter A, the last position of 1. This is for letter B, and the last position for 2, and this is for letter C. And finally, we return the total. So let's run it to make sure we don't have any syntax error. Okay, let's submit it. And here we go. And in terms of complexity, we scan the string exactly once. Every iteration perform only a few constant time operation. So the time complexity will be O of n. We store only the 3 integers, and this is still constant. So the space complexity is still O of 1. And this is the optimal solution because every character must be visited at least once. And this is the entire solution. Instead of checking millions of substrings, we only remember the last position of the 3 characters. One elegant observation transforms a brute force problem into a simple linear scan. If this explanation helped you understand the idea, don't forget to like the video and subscribe to the channel. Thanks for watching, and I'll see you in next video. Bye.